Void is the Viper OFP integration and debug team at Hill Air Force Base, and we build high-fidelity, concurrent F-16 simulators for engineers and pilots. We work within the Software Engineering Group, or SWEG, to develop new F-16 capabilities for the National Guard stationed in Tucson, Arizona. How do we fit into the big picture? Back in 1976, the first F-16 fighter jets, or Vipers, were introduced. Since then, the National Guard purchased several models, and they made extensive upgrades to the jet's hardware and software, introducing things like new radios, weapons, an electronic warfare suite, and flight computers. The main purpose of our team is to fix the huge disconnect between the F-16 software developers and the pilots who fly the new software. It takes weeks or months and thousands of dollars to transfer new software, test it, and put it on the jet. Then afterward, it's hard to return the correct feedback to the developers. Our team fills that void in communication between engineer and pilots. We do it by deploying the newest software onto a simulator that both groups can access. Through our work, F-16 engineers and the pilots can be in the same room, giving real-time feedback as the pilots are flying the software. When the sims aren't being used by the pilots, the engineers, pilots, and testers use them to become familiar with new releases, and they naturally validate the software stability. All this happens before the software ever goes out for system test and deployment, saving incredible amounts of time and money. That's what the Void simulator does, but what do the engineers get to do? We have an exciting mix of both software and hardware challenges. Our software, which is written primarily in C and C++, contains more than 1 million lines of code across 6 programming languages. Why so much software? We integrate actual F-16 embedded software from 6 other teams into a dynamic environment so that the jet thinks it's actually flying. The software is hosted on Linux and targets VxWorks, the real-time operating system used on the F-16. Beyond that integration, we write our own software using best practices such as automated tests and CI/CD for the new models and sensors on the F-16. Now, on the hardware side, we work with F-16 units like single-board computers called Power PCs and the pilot's helmet called the HEMIT. We simulate hardware, or 1553 MUX traffic, and use Ethernet to communicate with a myriad of other external models. We engineer the network, cutting and wiring cables and configuring VLANs, and we capture user inputs and outputs with a throttle and stick, touchscreens, gauges, and switches. With the combined hardware and software, we create an IEEE Distributed Interactive Simulation, or DIS, environment to fly alongside teammates and hostile entities. In this environment, the aircraft can send and receive radio messages, emit and identify radar signals, launch weapons, and fly collaborative missions. Then, we interface the entire environment with image generators to create a realistic 3D world to fly in. In the end, we configure and duplicate everything we've talked about into a force ship so that the real pilots can fly missions together. So, what do? We create high-fidelity, concurrent simulators in a dynamic environment for the F-16. Our team gets to experience all of the new F-16 updates while writing new embedded models to support the F-16 development. The challenges are compelling and the work is rewarding. We build the Void simulators.